The third form of DQN is called Duelling DQN. Why? Remember, we already know DQN, double DQN, and double DQN plus prioritized replay buffer, right? Now, the third DQN modification is dueling DQN. Why it was introduced? First, because temporal difference Q-learning networks tend to overestimate rewards in noisy environments. It quickly leads to non-optimal training outcomes where your network stucks in some unsuccessful trajectory and doesn't want to move anywhere else. The second problem is a moving target. This problem comes from the fact that the same network is responsible for choosing and evaluation actions, leading to training instability. Especially here, the same network is responsible for selecting and evaluating actions. It makes all the system unstable. And the solution was the double dueling DQN. The network predicts two values, the V, the value of being in state S, and the advantage. What is the advantage of taking this action in comparison with taking any other possible action in this state? The larger advantage, the larger probability for agent to pick particular action. Why it is important? It is important because this network considers two factors. First, how good is to be in some state at all, one point of view. A second point of view, which action is better to take in this state. While in the plain DQN or double DQN, we predict one value for a pair. We don't separate states and actions, taking them as one. Here is a state action pair. Here is how good to take it. And here we separate. We tell how good it is to be in some particular state statically. And then we're trying to understand what is the advantage of taking any particular action in this state. Here is the architecture of such a neural network. As you see, it has two heads. One head predicts values. The second head predicts the advantage of every action in this state. So being in this state, the agent can take action A1 or A2 or AN. And for each of these, we will predict its advantage. Next, those two values, V of S and A of SA, they are normalized to be on the same scale. The value of a state is added up with every advantage. And as a result, we have a Q values. Here is the code for it. This model will look like this. You have a feature extractors. If it's a dueling DQN, we first predict state values, and then we predict advantage. We add up them element-wise.